So the skill that we're going to cover now is writing linear and exponential functions. But before we do that, we have to be able to look at a situation and decide, is it linear or is it exponential? So these are some cues that it might be exponential, and these are some cues that it might be linear. If they're talking about a percentage, it's going to be exponential. If it says increasing or decreasing by a constant rate, it's going to be linear. But if it says increasing or decreasing by a fraction of the whole, like 2/3, a half, 5/2, 5/3, things of that nature, exponential. Anytime you're multiplying to get to the next value, we know it's exponential. Anytime you're dividing to get to the next value, is exponential, even though technically you're always going to multiply when it comes to exponential because that's your multiplier. And so when you're dividing, the number that you're multiplying by just happens to be between 0 and 1. And then another linear, if it says a fixed cost, or it says adding to get to the next value or subtracting to get to the next value. So here's some situations, and then you can decide if they're exponential or linear. So the bank account starts at $10 every month. The amount of the money in the account is tripled. That's multiplying by 3. Increases by 30. That means it's a constant rate each time. So that makes it linear, while this one is exponential. If I look at Saint bought a Rolex for $10,000 and the watch appreciates, which means it's increasing each year by 1.34%, Q got percentage. That means it's going to be exponential. Same thing with Cassie bought a car for $10,000 and the car depreciates, which means it's decreasing by 13.4%. But then it says Reggie went to the carnival with 50 tickets, and each time he rides a ride, he has to pay 6 tickets. So every ride, 6, 6, 6. Well, I feel like I shouldn't say 6 a million times like that, but you know what I mean. All right, that's going to be linear. Constant rate. There are 20,000 owls in the wild. Every decade, the number of owls is halved, which is another way of saying you're multiplying it by a portion of the whole, which is going to be exponential. And if you look here, 20,000 owls in the wild, every decade the number of owls decreases by 50,000. That really should be 5,000. I'm sorry, it shouldn't be decreasing by 50,000. That should be linear though, because it's a constant rate. A gym customers pay $50 for a membership plus $3 for each time they use the gym. 3, you add 3 each time, linear. And then these last two, it says library has 8,000 books and you're adding 500. So that means it's going to be linear. We know we add or subtract. And then for this one, it says it's growing the book collection by 3.5%. You see that percentage, you know is exponential. So the first step is being able to decide if it's linear or exponential. After you decide if it's linear, now we're going to go ahead and look at writing the equation for a linear function. So you have two parts to a linear equation. You have a constant, which is b for begin. That's where your y-intercept. And you have m, which is your slope. It's how you're changing over time. So if you look at this example, you're starting off with 500 because the elevator travels down from the top floor from 500 feet and it's decreasing 11 feet per second. So notice that we have a negative 11 as our slope because it's changing by decreasing by 11. And the starting rate, which is your y-intercept, which is 500, as you can see in the graph over here. If you look at a table, this is what your table looks like. And these are just some questions that can be answered associating with a linear function. So we have our domain, we have our range, we have your y-intercept and what does it mean in the context of this problem. Same thing for the x-intercept, the slope, and what does the point 45, 5 represent in the context. I'm gonna focus in on that one. 45 is my x value, while 5 is my y value. So what 45 represents is 45 time in seconds, while 5 is going to be the y value, which represents height. So that says in 45 seconds, the elevator is 5 feet from the ground. That's what that means in context. So let's look at another linear equation. Remember, the first thing you got to do is decide if it's linear or exponential, but after you decide it's linear, now you can write your equation. Travis is going to the state fair where he must pay a set price of $28 for admission, plus an additional $3 for a ticket to go on each ride. So B is for begin, you're beginning at $28. And then your cost is going to be increasing by 3. So instead of a negative 11 like we had in the last example, we have a plus 3 here. So when you look at your table, it's increasing. Notice your y values are increasing by 3 here. Notice that next to your x, you have your y value of 28, which is also your y-intercept, as you can see here. Notice that your graph is going up compared to the last one that's going down. And here are some other characteristics or some other questions that you should be able to answer given a linear function, ranging from the domain range, y-intercept and x-intercept, the slope, what does that mean, which is the cost of each ride, which is the $3, and then 1058, what does it mean in context? 10 is the x, so x is number of rides, so 10 rides. 58 is your y, which is the total cost. So if you ride 10 rides, it will cost $58. So now let's say you read a word problem and you said, I know this is exponential. Now that you know it's exponential, now you can write your equation. Now for exponential, it's going to increase or decrease. And it's going to increase or decrease by a percentage. If they say increase by 7%, you have to first turn the percent into a decimal by moving it to the decimal to the left twice. So 7%, the decimal is traditionally here. So moving it to the left 2 times, so that's 0.07. So you put 72 is your starting amount, or whatever your starting amount you put out front. And then it's 1 plus 0.07 if you're increasing. And it will be 1 minus 0.07 if you're decreasing. Notice that your base, your multiplier here is 0.93, which is less than 1, while this one is greater than 1, hence 1.07. And that's why if it's greater than 1, it's going to be increasing. If it's between 0 and 1, it's going to be decreasing. So we're going to have increase by 18%. You need to first turn it into a decimal by moving the decimal to the left twice. And you get 0.18. And then so 1 plus 0.18, 1 minus 0.18, increase and decrease. And then the same thing for this. So I'll move it to the left twice to get 0.216. So 1 plus 0.216 and 1 minus 0.216. All right, but notice that this top equation and the second equation, they're the exact same. Oftentimes you're going to see it like this, but these are equivalent. So now let's look at a word problem. Stephen has $320 in the account, and the account is appreciating 7.2% each year. How much will Stephen have in 3 years? We already know it's exponential because it's increasing by a percentage. So then now you put 320 out front, because that's what you're starting off with. 1 plus 7.2% at the decimal. Move the decimal to the left twice and you get 0.072. Remember, when you move the decimal to the left twice and you're like, man, I don't have enough space, that means you just put a 0 there. So the same thing here. I moved it to the once, I got 0.7. I moved it to another time and I don't have a number there. So I put 0.07. All right. So then 3 years. So that's when your exponent is 3. Now, if I just wanted the equation, you would leave 3 as x, and that will represent years. So whatever years you want, you plug in and get your answer. What I want you to realize as well, though, when you have that 1.072 as your base, or 1 plus 0.072 as your base, and you have a 3 as your exponent, that's just saying that you're taking this base and you're multiplying it 3 times. Taking the starting value, multiplying it 3 times. So if I wanted to find after year 4 and I already had year 3, I would just take this answer and multiply it by 1.072. And then take that answer and multiply it by 1.072. This is just an equation that we don't have to do that manually, but that's technically what's happening. Notice that when we said appreciate, we did 1 plus 0.072 for increasing 7.2%. The only thing different here is now you're going to be decreasing 7.2% because it says depreciating 7.2%. All right, so you can write 1 minus 0.072, which is equivalent to 0.928, which makes sense because it's depreciating, decreasing, which means your base or multiplier is going to be between 0 and 1.